Hello, my name is Heli Hendesi, and I'm Senior Content Manager at ASCM. It is my pleasure to be your host for today's webinar, Smart Operations, Digital Capabilities Model. Today, I'm joined with Vadakkath. Vishwa works in Deloitte's manufacturing strategy and smart operations practice and leads the development of the smart operation pillar of the Digital Capability Model, DCM. His work emphasizes delivering sustainable value for companies through end-to-end supply chain transformations. And he serves domestic and international clients across industries, including industrial product, technology, and consumer goods. Prior to Deloitte, he led teams across lean manufacturing, quality assurance, and plant engineering at Caterpillar. He holds an MBA in Supply Chain Management, Strategy and Finance from Penn State and a bachelor's degree in Mechanical Engineer from Amrita University in India. It is now my pleasure to present Vishwa.
Hey, thanks, Heli. Thanks for the introduction and thanks for the opportunity here. I think it's a very interesting topic. I've loved working on the smart operations framework with my team here, and I'm very glad to get this chance to talk to you all about it. It's always been a journey, right? We've been 2 years into this journey of development, so sessions like these and the feedback that we get from them that really help us refine and mature this model. So let's get right into it. We'll begin with an overview of the digital capabilities model, of which smart operations is a part of. Talk a little bit about the journey so far and what we have in the pipeline, and then get into smart operations. So the capabilities within smart operations, the matrices, how does smart operations connect to the other parts of the digital capabilities model, a little bit about the model maturity, capability maturity models, and then I'll end with some use cases to bring to life really the power of this capabilities model and how it has really helped clients so far. I also want to spend a little bit of time on the website, on the DCM public domain, to walk you through some of the features that are better done in an interactive page than on a PowerPoint. So we'll spend a little bit of time there as well. So DCM, Digital Capability Model, what is it? Why are we talking about it now? Let's get into it. So I think at its most basic level, supply chains are all about matching demand with supply, right? So if you're a supply chain professional, you've got just one job to do. That's make as many products and deliver it on time for what the demand is, right? But if only it was that easy, right? So if you're someone in the planning domain, you need to make your demand plans, create the supply plans, and that's all you're supposed to do. On the sourcing side, you procure the material that you need. On the manufacturing side, you just make against your supply plan. On the delivery side, you get products out of the door to your customer on time and then handle returns as and when needed. But the problem is there are uncertainties along the way, right? It is not easy to match demand with supply all the time. And one of the best examples and the kind of problems that we've lived with, which has been the problem many years ago, still is the bullwhip effect, right? So from about just, let's say a customer orders just 10 parts, when you get from the retailer to the distributor, to the manufacturer, to the supplier, that 10 becomes, let's say, 50 and 100, right? So with no visibility across the supply chain end to end, you tend to add buffers along the way, a safety stock at each stage in the chain, just to make sure that you service your customer as well as you can, but in the process, you lose out on efficiencies. So that's where the digital capabilities model or the digital supply network comes into play, right? So what we're moving away from is the linear sequential model that was the foundation of SCORE to a supply network, which is bidirectional and digitally enabled. So what is the bidirectional part here? The bidirectional part is the fact that at every stage in this network, you would have a signal not only in the forward direction to the next step in the process, but to all other links in the network, right? On what's failing, what's happening well, what are the places where there needs an intervention. So signals get passed on to all parts of the network, and the connection is live and always active, right? And the digital enablement piece is to do with technology, right? So very clearly there are technologies at each node in the network that really helps do things faster, be more efficient, and also do it in a cost efficient manner. And we'll talk a little bit more about that in the smart operations domain as we go through this. Now, the question is to move from supply chains to digital supply networks, how do we do this? That's where the capabilities model, the digital capabilities model comes into play. For many of you who are well bought into SCORE and SCORE buffs out there, you would know that the plan, source, make, deliver, return, and enable framework has been extremely robust and has served the industry for many years, right? So the foundation still remains the same. We are building off SCORE and building the digital capabilities model, and obviously enhancing it with all the new technology that exists at each node in the network. So plan as a SCORE domain is now what we're calling synchronized planning, right? So this takes a more network view on planning, right? So starting from the enterprise operations, think of this sales and operations planning, connecting the requirement from the sales side to create plans that are required for the supply side of the network, right? Source is intelligent supply, finding more meaningful ways with technology today to add value to the procurement side of the world. Make is smart operations. We are broadening the definition, and we'll get into this a little bit more later, broadening the definition of make to include not only the product side of the world, but also services, right? And that's why we're not calling it smart manufacturing, it's smart operations, right? Deliver and return, at its most basic sense, what are the ways to get the right parts to the right people at the right time is what dynamic fulfillment is all about. And what you would notice is there are two elements in here that are very integral to any supply chain that we've called out as new level 1 capabilities. One is connected customer. So in the olden days, we used to think of a customer transaction as a one-time process, right? You buy the product from a store or even online, and then you move on. But today, the customer integration part to the supply chain is extremely important, right? So whether it is during the life of the product, monitoring whether something is going wrong, sending a signal back to the manufacturer or the OEM, and let's say for a fridge, ordering filters on time, or even at the end of life, finding ways to recycle, send the part back, or send the whole product back for a replacement. All of that is today possible because you don't think the customer as the first link in the network, but a link that is active and always part of the network, right? So that's an addition. And then another addition you would notice is product development, right? So it's very common in the industry to see the R&D department is separate from the supply chain department, and the function of product development is very distinct from the function of actually meeting the demand for a particular product or a service even. That is changing and changing fast because throughout the supply chain, whether it's designed for manufacturing, whether it is finding ways to get the product closer to what a customer really wants by knowing customer preferences and customer usage trends. All of that is now being considered as part of product development, as is a very integral part of the supply network. So what we have moved towards is actually 6 level 1 capabilities you see here. And beneath them, there are about 39 level 2 capabilities. And like I said at the start, we are learning and we are evolving. And the idea would be to get to a more robust model over the next year and a half. One of the things to call out here again is the fact that this is all about a whole systems thinking, right? Optimization cannot be done in any one part of the network without impacting the rest of the network. So any improvement that's done has a trade-off elsewhere. So the real deal here is about understanding the impact that you make when you make a change, let's say in planning, to operations and fulfillment in other areas. And that whole systems thinking is the foundation of what the digital capabilities model is all about. Now, we won't get a whole lot into the how part of it. How do you make this transformation? But at its most basic level, what it is it's enabled by what we're calling digital disciplines. And so these are sense, collaborate, optimize, and respond, right? So sense, have sensors and methodologies to measure and document data wherever the activity happens. Send that data to all the people and all the points in the network that really want to make use of it, right? So you collaborate, and then you analyze and you optimize the responses that are required, and you respond proactively, right? So sense, collaborate, optimize, and respond are the digital disciplines that really make this happen. Now we just for the sake of making the point here, this is the new score, right? So along the 5-6 steps that you have in the score model, if we were to bring in and embed sense, collaborate, optimize, and respond, then that really is what the digital capability model is all about, right? So that is the new score. It's been a journey. We started back in 2018. Meaning Deloitte with ASCM, where in the first release in 2019, we framed the basic elements in the model, the capabilities, the vision, some personas and examples. And in the most recent release, we built on that. And we now have level 2 capabilities refined and mapped to all parts of the network. And this is something that's very exciting, and I want to show you on the website later in the webinar. Matrices defined for all the level 1 capabilities. And also we have mapped the DCM capabilities to the scope processes. So as I was mentioning, it's a level up. It is absorbing the score elements and making sure that it works in this new technology enabled era. Moving forward, we're going to talk a little bit more and have a point of view developed on what the center of the model is all about, right? So it's not enough to have these individual elements created and connected. You also need a way to define how the organization is to be set up to support all of this. How do you do performance management? How do you interact with areas outside of the supply network, sales, finance? So that's the thinking and point of view that you will see come up on the public website pretty soon and as part of the upcoming releases. And so also you will see an implementation methodology on how to get to the results that this model promises. And in cases where you've already started down digital initiatives, how can you do that faster and accelerate and get to benefits faster? So that's a little bit about DCM and what the model is about and the journey that we have gone through so far and what's coming up in the next year and a half. So really getting into smart operations, what it is, and the details of capabilities within smart operations. I want to start this with a video. So I'm going to jump to that and then get into the content right after.
History class taught us about the Industrial Revolution, when steam power changed how things were manufactured. But there hasn't been just one industrial revolution. The manufacturing industry has reinvented itself many times. The first industrial revolution is the familiar one. Beginning in the late 18th century, manufacturers used steam engines and hydraulic power in factories to make production more efficient. The second revolution began in the late 19th century when electricity and assembly lines made mass production possible. The third took off in the 60s when advances in computing enabled us to program machines and networks. Today, we're at the beginning of a fourth industrial revolution. Industry 4.0 is about connecting the digital and physical worlds. Today, most manufacturers' key assets are a part of the physical world. The workers, machines, tools, and inventories that drive both the production process and the end product that customers use every day. But emerging technologies allow manufacturers to use data produced by these physical assets to drive insights based on data. These technologies will enable the construction of new solutions to some of the oldest and toughest challenges manufacturers face in growing and operating their businesses. Eliminating unplanned downtime in the factory. Ensuring you never start work on the production floor that can't be finished with the material, labor, and machines you have on hand. Tripling the leverage you get from costly support labor and specialized tech talent. Changing the dynamics of your channel and creating new sources of revenue. Enabling your products to sell services for you. Growing your data business as big as your product business. Using customer and channel connectivity to achieve unprecedented levels of customer service. And the changes for the industry as a whole will be even broader, as broad as we've seen in past revolutions. Industry 4.0 will change the basis of competition, alter how manufacturers win customers, shake up the structure of the manufacturing industry, and give you the opportunity to make history.
So that video is slightly dated, but it conveys the point, right? The manufacturing that we are familiar with and aware of from 10 years ago, 20 years ago is changing, right? And there is a definite advantage, a step change that technology is really bringing into the manufacturing domain and more broadly for operations end to end, right? So that's what smart operations is all about. How do you do things more efficiently, more quickly, and take out manual repetitive jobs wherever that can be done and augmented by really machines and technology, right? So getting into the definition, what it is, smart operations is a highly responsive, adaptive, digitized and connected capability integrated into the digital supply network that synchronizes all aspects of productions and operations. So the idea here is to drive performance and safety improvements throughout the life cycle of the product, and also get into the space of repair and overhaul. What are the ways technology can help with repair and overhaul? So one of the things that I get asked, and over the last year and a half, as part of this initiative, what I've been hearing from my friends is like, what is so smart about operations now that wasn't there before, right? So wasn't operations smart before? The answer is yes, right? And as this video clearly showed, everything that was done in the past was one level better than what was there before, right? Whether it's creating an automated scissor or an arm extension to clear out burrs from your machine shop, or whether it is having an extra step to get to your machine so that you have a more ergonomic setup where you work on a daily basis. All of that is improvement, and all of that really makes manufacturing and operations faster and seamless. But what's happened more recently is with technology, there are ways to connect machines to material to man. So the man-machine material bridge is so much more seamless today with technology and with Internet of Things and sensors that not in every instance do we need humans to focus on these mundane and repetitive jobs, right? So one big example is that of typical time studies that you do in operation settings, right? So you would go to, let's say, an assembly line, you would stand there with a stopwatch, observe the movement, observe the material and man movement, and then you say, okay, here are the places where you can really do things faster. Here are the ways you can rearrange so that things can be more efficient. Now, all of that today can be really done with digital process twins, right? So you can create a replica of the physical world as simulation on a laptop, for example, or a control center, and you would be able to observe exactly what happens on the shop floor as and when it happens, and you make, and what also happens is the analytics that comes out of it is also directly there. So you would see if machines are waiting on material, you would see if someone is moving more than he or she needs to on the shop floor and there's a shorter route. All of that is automatically traced, tracked, and insights are thrown at the shop floor manager to act on. So that's just one example of how technology today can really simplify and do activities that were done before much more faster and much more efficiently. It is never the case of man versus machine, right? Smart operations doesn't mean that we're going to take humans out of the picture. It's really about augmenting human intelligence with machine intelligence, right? And augmenting human physical capability with machine capability. And the idea is to do all of this in an extremely safe manner, right? So that's the premise here of smart operations. Now, as a model, we have evolved over the last 2 years since the model has been out there for people to see, comment on. We've got a whole lot of feedback. And even as a practice, we've been implementing this at clients and getting feedback and refining this based on that. We have a whole lot of supply chain focused programs in the US where professors take a look at this and comment on this, and we've evolved it, right? So what you see here is the set of level 2 capabilities within smart operations, 3 of which have been very recently released earlier this year in 2021, and the others are have been refined, right, based on these inputs. So I will get into the details of what the capability contains and the level 3 capabilities and so on. But at its most basic level, we have one capability that focuses on strategy for operations, right? So how would you determine where to set up your new plant? Do you need to outsource? Do you make versus buy? So do you find ways to, what are the new ways you can collaborate with the other technology companies to enhance your current operations? Those are some of the things that you cover here in operation strategy. Augmented workforce is the people-centric capability. And we will talk a little bit more about how this technology help in de-skilling labor, in enhancing worker safety, and so on. So that's what this is about. Total operation synchronization, TOS, is the planning capability within smart operations, right? So you get the supply plan, but then plan by definition will change. There are disruptions that happen. So how do you make sure that a change to a material plan, for example, is communicated well and in a timely manner to adjust for other plan changes for assets, for workforce, and everything else in the operation setting. Agile operations execution. So this is where the real execution happens, right? Converting of the raw material into the finished good or the actual delivery of service. That's what agile operations execution covers. EOS, efficient operation support, is the support capability, right? So very simply think the maintenance side of the world, the quality side of the world, energy management, things of that nature. And operations command center, this is the analytics and visualization wing within smart operations. How do you make sure you monitor, analyze, and give feedback to the rest of these 5 capabilities in a way that they can operate smartly and be in sync all the time, right? So that's what operations command center is all about. So a little bit more about these capabilities, right? So like I said, operation strategy is about getting to operation decisions knowing that resource is a constraint, right? So how do you make the best use of available resources? The example that I mentioned earlier on digital process twin is, I think, one of the best use cases for operation strategy, where when you think of an expansion of a plant, just because you are capacity constrained, um, in the era past, what you would do is look at where your resources are, right? I mean, where can I get my raw material fastest? Where I can, where am I closest with customer even sometimes? But the considerations are very different today, right? I mean, do I have network connectivity there? How well do I translate insights from a customer to what is required in the plant through the supply network? All of that are considerations. Now, digital process twins really help simulate that, because even before you set up a plant, even before you really think of your next physical plant, if you want to expand, you can simulate all of that as a network and then play around with what if scenarios, right? What if this plant was 10 more miles away? Or what if there was additional inventory stocked up at a distribution center versus at the plant? Those simulations become so much more real, and then that helps you make decisions much more in a much more data-driven manner. Augmented workforce, like I said, it's all about enhancing worker safety, productivity, and performance by finding ways to take out the repetitive jobs, right? So one example is exoskeletons to improve worker ergonomics. And then one of my favorite examples is the AR goggles, right? So you wouldn't expect everyone on the shop floor to know every job or even troubleshoot for that matter, right? So someone who is a vertical turning center expert may not know how to run a horizontal milling machine. But so long as you know the basic operations and fundamentals of how to operate a CNC machine, if you have AR goggles and assistants, right, on a personal device assistant next to you, then instructions can go to the point of use when needed, if there's a breakdown or if there are instructions that are required to troubleshoot, so that you really don't need everyone to know everything. You can actually have an expert somewhere really pass on that message, and then AR goggles really translate that even visually into things that they really need to act on and touch and move around, etc. Actually, it's a fantastic use case for maintenance, frankly. Total operation synchronization, scheduling and allocating limited resources, right? So what's new and the technology that really enables this is the sensors, right? So there are RFIDs in the actual inventory, even if it's work in progress or finished goods, you know where exactly the material is. So you plan for the next match accordingly. People that when they come into the plant have RFI, I mean, they have badges that they swipe, and you know exactly where they are and what job is going to be scheduled for them in the next shift. So that tracking and planning is so much more synchronized. And the idea is to coordinate between that material plan, the workforce plan, and the asset plan seamlessly moving forward. Agile operations execution, there is a whole lot that technology has done to really simplify the actual operations, right? So 3D printing, a fantastic example, rapid prototyping. At its most basic level, it is tasks where it can be automated, you involve a robot, right? So if you're in a car manufacturing plant, for example, day in, day out, where people need to pick from a kit or a storage location, assemble a part, the car moves on, and then you do the same thing again and again. That repetitive task can really be automated with a robotic arm, right? So that's just one example, right? But tasks where repetitive and can be automated, can be replaced with a machine's help. That's a fantastic use case for agile operations execution. Operations support. Here again, technology has ways to help maintenance folks predict failure even before that happens. And that's one of the use cases that we'll be discussing later today. In addition, finding ways to mitigate failure, even at the supplier end, is something that this capability will allow to do. So example being supplier information through intelligent supply gets conveyed to EOS, and even before the supplier expects something to go wrong, or even before the supplier ships the part, you can actually predict through failure modes and effect analysis, for example, and send back a signal to the supplier saying, hey, look at that one parameter in line number 3 in that particular bay, because it seems like it's off and it's trending in the wrong direction, right? And it's a much more proactive way of troubleshooting than really wait for the part to really get to your plant and then identify the defect and then communicate back. Operations Command Center, again, think of this as a place within the factory that really monitors the full show, right? So you have the conductor of the orchestra, the command center manager sitting there, exactly seeing what happens, when it happens, and if there is intervention required at a particular place, there are alerts that come up on, let's say, dashboards in the command center, and the command center manager can really pass on that message to the closest person there, right? So a signal gets transmitted as and when needed, and then you don't really need to have people man individual workstations if that's not required for that particular job. So that's a little bit about the capabilities at the second level, and it again breaks down into the third level. We as Deloitte, we've developed this perspective at the third level. It is not yet public on the public website, but it is from the learnings from projects that we have tried to compile here, right? So I've talked about the use cases across the 6 different L2s. So as you would see, operation strategy, it contains things like network optimization, outsourcing strategy, augmented workforce, consists things like robotic process and cognitive automation, right? And then finding ways to have real-time assistance, total operation synchronization, asset planning, material planning, workforce planning, those are the big elements there. Agile operations execution. So this is a part that I did not mention before, but even when you connect, when you need to build out a new product and prove it out in your operation setting, that is the first step, right? So how would you collaborate with the product development side of the supply chain to do that efficiently and on a timely manner so that you don't miss launch dates, etc. And then you really get into the make product, deliver service section, which is where technology, like I explained, whether it be robotic arms, whether it be exoskeletons, can really help accelerate and do things faster and safer. Operation support, this quality, predictive quality, there is asset intelligence and performance management, energy optimization, waste management. These are some of the big ones. And operations command center, like I said, analytics capability, where you have ways to analyze, respond, and even control to a large extent what happens in the plant, where you don't really need a human intervention. You can autonomously control processes. And one of the examples today will be around autonomous process control. Now, a lot of what we just talked about can only succeed if the data that comes out of that activity or a process step is measured in a timely manner, right? So the metrics dimension to the capabilities that we released last October is extremely critical, right? So as you would notice in this list, these are key performance indicators for each of the different level 2 capabilities that you see here. And some of these that you see in bold are net new, right? So these are not matrices that were part of score. So it's an enhancement. And some of that is kind of self-explanatory, right? So for example, informational defect. You wouldn't think of a need for monitoring data defects in the years past, right? You would really look at the product, you look at it for form, fit, and function, and that's it. Right? Today, even the data that might come through could be defective, could be inaccurate, there could be a time lag. So a way to monitor the cleanliness and doing a sanity check on the data is also an important element, right? So that's one of the matrices that's an addition here. And then there are some more obvious ones that have been added to score in DCM with this extra focus that we are bringing in on the workforce side, right? So whether it's monitoring training effectiveness, monitoring safety, environmental incidents, I think those are additions to the score model based on more recent feedback. So I don't want to spend a whole lot of time on the metrics, but it is an extremely critical element. And one of the things that we're working on now is to see how do you build a hierarchy of these matrices, right? So not everything is important to everyone at all points in time, right? So at what levels in the organization do these matrices matter? So we can really tier them in a way that is usable at different levels in the organization. Now, one of the other very critical elements is the capability maturity model. Again, there's a whole lot of text, so don't want to spend a whole lot of time, but for people in the industry, people who are trying to adopt smart operations, I think this is an extremely critical element, because what this is trying to show is for every capability, there is a way to do it in its most basic form, which is what we're talking as typical, and then there are industry leading practices, right? So from what we've experienced through implementations in the past, we've tried to synthesize all of that and show a gradient from ad hoc to industry leading for each of these different capabilities. So I'll just pick a couple of examples. In operation strategy, it's not going to be a reactive communication to the rest of the organization, whether it's sales, whether it's planning. But in a leading, once this capability is implemented and once you mature this, one of the leading practices would be to have scenario-based simulations, not for the plant that you're considering right now, for other plants in the network, and also to the suppliers, right? So it's going to be a more proactive method of communication and response. We've touched on some of the examples before, so I do not want to spend a whole lot of time here. But as you see, this framework and the thinking over here will really help assess where you stand if you're a manufacturer on what part of the scale do you stand, right? And how do you really enhance incrementally using technology, right? One of the most basic forms of this is what we have tried to capture in the digital readiness survey that's already out in the digital capabilities model, but this gets into the next level of detail at a functional level. Now, before I bring up a few use cases to explain how this has really helped manufacturers, I want to take a little bit of time to talk about one other element in specifically on the website. And this also gives you a chance to look at the dcm.ascm.org if you've not already been here. This is the portal, right? dcm.ascm.org is where the model resides right now. When you go in, you see a capability definition and all the capabilities listed here. And as you go into each capability, let's say smart operations in this instance, you can click on learn more. So if you're an ASCM member, you should be able to log in with your member credentials, and you will be able to see the details of some of the elements that I talked about, right? So definitions, vision, capability journey map, some personas, right? And then again, you can actually go back here and then click into each of the different L2s and learn more about it, right? So one of the things I really wanted to show on the website is this, right? The level 2 capability mapping. And this is what makes it a network, right? A supply network. When you click on any L2 anywhere in the network, you would see information outputs and information input, right? The intent here is to say that every capability, the 39 and level 2 capabilities that you see in the network are all related to the rest of the network. And as you hover on these lines and click on them, you see the kind of relationship, right? How strong is that relationship? How frequently should that information be passed on? And are there places where you really need a whole lot of input from across the network, right? This is a fantastic example, right? For you to synchronize and do operations well within the four walls of a factory, you do need inputs from across the network. And this kind of literally shows that as you click on it, right? So if you have not already spent time on the website, I think this is a great place to learn more about not just smart operations, but the broader additional capabilities model. So just wanted to show you this and specifically point you to the level 2 capability mapping here. Now, getting back into the last segment we have here, use cases. Deloitte did a survey, I think in 2019 with MAPI, which is an organization that studies manufacturing operations. And the question was simple, right? How many people have really started on smart operations initiatives? If you have already done it, what are the results that you're seeing? And then if you have not done it, why not, right? So it's an even split. 49% have not started smart operations initiatives, and about 51% of the survey respondents have really started initiatives, right? And for the most part, the people who have really started on these have reaped benefits and significant benefits, right? So everyone says that these the tools and technology that enable smart operations will be the main driver for success and competitiveness in the future, right? So that's a very clear message. And some of the reasons why people have not started are pretty obvious, right? The fact that you don't know where to start, the lack of experience, or the difficulty to adapt to this change, or the fact that you don't really have a compelling business case in the sense that you can't quantify. If I invest $1 million in sensors, what am I really going to get? How long is it going to take me to really reap benefits and be more efficient with my production and so on? Right. So those are some of the things that we've heard. But at the end of the day, what is extremely clear, and that's something that I want to really bring to life with some examples here, is the fact that the traditional Lean Six Sigma methodology for continuous improvement in manufacturing settings or operation settings, that adds value for sure, but that value kind of plateaus out pretty soon, right? So for the incremental effort, you do get value pretty significantly in the initial stages, but then beyond a point, that value addition is extremely slow. That's where the technology, the tools, the methodologies that we just talked about so far really add value. And these are just some examples, right? Whether it's Internet of Things, whether it is big data analytics, predictive analytics, they just really add a step change to the way you can get and reap benefits in your operation settings, right? Improving efficiency and productivity. So that's extremely clear from some of the implementations we've done so far. And numbers say the story, right? So whether it be 20% improvement in asset efficiency, right? Think of it as utilization improvement, having very limited downtime, 30% improved quality, right? Finding ways to reduce scrap rate, getting more yield from the line, 30% reduced cost, right? Whether it's labor cost, sourcing cost, inventory levels, maintenance, warranty costs, and more than anything else, improve safety and sustainability, right? Having ways to help improve ergonomics in the shop floor, finding ways to be more proactive in the way you address sustainability issues and measure those more than anything else, right? So those are very significant improvements that we've seen at some of our clients through these implementations. Now, the example that I want to first share here is on packaged goods manufacturer. So this food packaging company had this problem of having the grinder machine blades fail unpredictably. This was pretty frequent and annoying, obviously, as you can imagine. But it was not for the fact that there was not a preventive maintenance schedule in place, right? So they did go against a particular schedule and monitor these machines. It was still failing. So what was really done was really measure the sound and vibration on these machines, right? So the noise levels can really, when monitored closely, tell you whether the blade is a good blade or a bad blade, right? Healthy or dull, right? And then when you measure the vibration, you can still know if there's something that's not usual, right? Not within norms. And that monitoring those parameters, see whether they're in range or trending in one direction, really helped predict failures and avert them well in advance, right? So you intervene and then you take care of it much earlier. So what this did was very clearly it made the machine, it reduced machine downtime. While you might think the 1% improvement in OEE is just minimal, it really isn't, because what you're looking at is almost a $5 million saving per plant. And that's not surprising, because having a machine down not only implies there's a disruption for that particular operation, but you might be keeping something else waiting, especially in a process manufacturing setting like this. The implications are huge if the material has to be trashed because of long wait times. So this was a very tangible example of how you could really predict machine failure and really avert it. And there are extension of this use case where you can really have ways to autonomously order parts, right? So knowing that something is going to fail, can I look at my spare part inventory and trigger purchase orders well in advance, right? And then only for extremely high value ones, put a notification for the spare part manager and ask him or her to really approve that, right? This last use case here is on, it's on a factory floor that makes cars. Very typical problem, and not probably a problem that everyone in any kind of plant might be familiar with or can relate to. It's about assigning people to jobs, right? So when you get into a shift, you really want to be very optimal in the way you assign workforce to different workstations. But this was getting extremely complicated with people coming in late, the supervisor not knowing the level of skill that's required for a particular job because people keep changing. And the impact of delay is usually very huge. In this instance, you're talking about $10,000 per minute of delay. So what was done is, think of this as a fantastic example of a total operation synchronization use case where you convert all of the spreadsheet and tribal knowledge into logic that can be coded, and you keep track of the worker skills, seniority, preferences, etc. Right? So every worker, you have a profile with very clear levels mentioned for seniority and skill sets. And then when people badge in, you very quickly are able to match the skill sets to the presence of that individual in the plant. And then 5 minutes before the shift, you would see that allocations are already ready in front of you in a iPad, for example. This is extremely beneficial because now the supervisor need not be someone with experience or need not have that direct knowledge on the level of skill set, because it's already available in the database, right? So reduces a whole lot of stress, if not anything else, right? The extension to this is, again, use cases where you can predict if a particular person is put on a particular job 2 days from now or next week, will that part really fail, right? And that might be a little scary for some people, but what it's doing is knowing the skill levels, knowing previous errors that a particular individual has made. You can extrapolate and say, if you put this particular person in this particular workstation for a job that is net new, for example, or that requires this particular skill set, this is the kind of failure that you might expect, right? So you kind of coach them, you support them with information that's required. So I hope that gives a good idea of what smart operations can do and what it has done. And I would like to conclude by saying that this is only the beginning of the journey, right? So we are talking about Industry 4.0 and things that smart operations can do. But really, today we're talking about Industry 5.0, right, where robots and humans really work hand in hand next to each other. So this is just scratching the surface, really. Whatever we talked about, while adoption is still maturing and people are just getting into it, there's also thinking around the next level of deployment with Industry 5.0 and enhancing cognitive abilities with artificial intelligence, machine learning, etc. So it's a fantastic area to be in. If you're on the fence about it, I think it's a great area to be in, and there's always something to learn, and I've always enjoyed being part of this domain. So with that, I think we can open up a question, Sally.
Wonderful. Thank you, Vishwa. Really great content. So here are a couple of questions for you. The results from these smart operations deployments seem very impressive. Corporate leaders who are watching this webinar might be asking right now, where do I start? So can you please elaborate how to approach these digital transformations?
Yeah, so we haven't really spoken about the how part of it, right? So we talked about smart operations, what it is, what the model helps us do. And maybe that's a fantastic topic of discussion for a future webinar. But at its most basic level, what we usually do is we go in with a maturity assessment, right? So we call it capability maturity assessments. It can either be done as a facilitated workshop, or you fill up a survey. And what it does is gives you an idea of where the priorities lie in terms of what should be the focus in the future, and then how mature are you compared to your peers in the industry, right? Knowing that maturity level, you would really then go pilot it, typically either pick one plant or even one section or a workstation in a plant to try it out, and then you scale it, right? So we usually say you think big and broad, you start small, and then you scale fast. So that's usually the approach we take. And one of the things that we've seen as a common pitfall or thing that keeps people from really starting, as you might have seen in that initial stat that I shared, is people hold being perfect as the enemy of being good. So the idea is to really start somewhere, right? There's always benefits to gain from these deployments. So really start and pilot a new scale.
Great. So another question is, all of the various technologies that enable smart operations, which one do you think will have the biggest impact in supply chain industry in the next 5 to 10 years? That's just a hard question, I know.
It's a good question. And the thing is, there's not one I can pick, but I mean, I think we've talked about a whole lot during the presentation. So things like digital process twins, things like exoskeletons, just the function of having sensors in machines, and then finding, I think the easy part is putting the sensors on, but having analytics to bring together the best insights from that data from machine operation is extremely powerful. But if you were to ask me to pick one, it's probably 3D printing in its next form, right? So today we have 3D printers that really build on what used to be the old rapid prototyping models, where in the future you can, depending on how when material strength improves and when the scale of manufacturing improves on 3D printers, I think we can do wonders, right? One of the things that happen indirectly is the fact that material wastage is almost entirely eliminated, because you're not shaving off material, you're really adding what is really required for a particular component. And it's extremely wondrous what 3D printing can do when the scale just becomes big. And one of the things that I learned recently is Xerox, known for its 2D printing many years ago, is now getting into 3D printing. So I think people really see this as an opportunity, and think there's a whole lot that can be done in that space.
Thank you. So I think we have time for one more question. In your presentation, you mentioned about Industry 5.0, humans and robots working hand in hand. So the way manufacturing and operations is evolving, the talent pool which is required to support that will also evolve. So do you think some of the roles in today's manufacturing industry will be ceased to exist in the future?
Yeah, very interesting and pertinent question. And this is something that we, as Deloitte, have also been trying to figure out with our human capital practice, right? Trying to further our thinking around this. The short answer is yes. Yes, some roles will cease to exist. It'll start dwindling and then it'll cease to exist. But then that also means new roles will emerge, right? So we never talked about a digital process twin in the past. Now you would need someone with operations engineering capabilities, analytics capabilities to really build and monitor digital process twins, for example. At its most basic level, some examples of things that might cease to exist are repetitive jobs, right? Like we said, in a car manufacturing plant, if you keep picking something and putting it in one place, that's not something you want to keep doing for an 8-hour shift. So why not use a robotic arm for that? Or quality inspection. Just to inspect the form, fit, and function, you don't need people. You need people to do the critical thinking afterwards to get to the root cause. So I think there will be change, and it is all in the right direction, because I think what we're thinking about is having that monotonous job set of skill sets removed, and then people focusing on creativity, critical thinking, and finding ways to engage with other people much better, right? And the rest of the organization much better. So I think skill sets that are soft skill sets, so to speak, will be more in demand. And I think that'll only complement what machines can really do on the shop floor for us with all the repetitive jobs.
Great. Vishwa, I want to thank you again for taking the time and joining us today. Unfortunately, that's all the time that we have for today. This concludes today's webinar. Thank you all for participating. All contents and materials included in this ASCM online event are the property of ASCM and are protected by the United States and international copyright laws. All rights are reserved.